and it holds DNA. And in the center of this nucleus is the nucleolus, aka Carl. Carl's a good person. And he creates ribosomes, which are copy machines in this example. And they go out of the DNA, or the nucleus, and attach to the rough ER and go.
Does Carl make the ribosomes?
Carl does make the ribosomes. So these ribosomes.
But this is going to be sharing. What's interesting about it is this electron is not shared equally between the two. What happens is run. She's going to run, and now when she gets to oxygen, she's going to slow down and check him out, and then she's going to run back, and then she's going to stay, and then she's going to run back again, and then she's going to slow down and check him out, right? She's going to run back again, run real fast, and she's not going to stay there. No, she's going to run back again. Is he going to stop? So look here, guys. Is that electron, is it shared equally?
No.
Where's it spending almost all of its time at?
With the actual
with the oxygen. So if this oxygen had all of its own electrons and it had another electron, would it sort of have a charge?
Yes.
Yeah, what would that charge sort of be? Positive or negative? Be negative, wouldn't it? It already has its own electron, plus it has this one. So wouldn't it sort of be negative?
Yes, sir.
Okay, what about the pseudo-hottie? If its electron is constantly leaving and going down there, does it have a charge?
Positive.
Positive.
Gallium phosphate. 19. Hydrogen chloride.
What is it?
Hydrochloric acid.
There's no charges.
It's all you, man.
It's all me. Number 5. Potassium sulfide. Boom!
Chicken wire fenced in section here, and I'm just going to kind of demonstrate for you selectively permeable, right? I mean, these balls obviously will not go through all those. She's a little scared. Something really big. By the way, we know, would this be more likely to be, let's think about it, would this, if it won't go through, is this more likely water soluble or lipid soluble?
Water soluble.
Explain that to me, Shine. What do you mean water soluble?
It can go through water, but it can't, since it's not lipid soluble, it won't be able to go through the phospholipid bilayer.
Excellent. So, right? So this might be water soluble instead of lipid soluble. Also, is this really large in size?
Yes.
Can big things go through the membrane?
No.
No, a lot of times they can't. What do we call a big thing? Starts with an M.
Macromolecules.
Macromolecules. There are 4 macromolecules. Do you remember what they are?
Lipids.
Lipids.
Proteins.
Carbohydrates.
And
Nucleic acids. Very good. Now, let's say that I had a small thing. I'll throw this one here. Not too hard. There you go. Did not work. This one right here, a little faster. Did not work. If this right here, if it would go through it, I'm not going to throw it at you, but you can see that does go right through the membrane, right? Number one, we see that it's small, right? We would expect it to be small. Would we expect it to be polar or non-polar?
Go.
Trisilicon tetranitride.
Ding.
Boron tribromide.
Ding.
Vanadium 2 sulfur.
Calcium 2 phosphate.
No, it's just vanadium sulfur.
No, what do you mean?
The other one.
Dinitrate tetrasulfide.
It'll be
Dom. S. I really need to have these. Freaking get look here. So that they like switch names. Centrioles are okay, but do not set it right there.
I don't know if I got that.
4s2, 4p6, 5s.
You sunk my aircraft carrier once again.
Yeah! AR.
Watch what she does here. So let's think. We got to figure out what the oxidation state or the charge of copper is, right? So let's let's go over here. Let's look at S. What is there's? How many S's are there? 1 or 2? There's only 1 S. What's the charge of that 1 S? 2 negative. So I've got a 2 negative there, and I had an H and an OH, and I let that drop to the ground. Would that be an example of a reaction?
Yes.
What kind of reaction?
Dehydration.
Dehydration synthesis reaction, and that's how we make a carbohydrate. So on 3, I want y'all to show me the making of a carbohydrate. 1, 2, 3, go.
Oh, yeah.
Scoot it together, scoot it together, scoot it together.
It's all amazing.
All right, and now y'all have made a carbohydrate, complex carbohydrate, through the process of what? Dehydration synthesis. And all of y'all represent what kind of bonds? Glycidic linkage. All right, that's good. You done?
Is I know this one. I'm thinking it's anaphase.
1 or 2. There's at least one in anaphase 2, I remember. Taylor, God dang it.
We're all done. You know, S
S is in the interface.
As long as, because it takes,
Then you got like,
because elongate is 2 yards long, isn't it? Or,
yeah, 2 meters, those meters. Hey, and then
G2.
dose.
Yeah, we'll have that.
They emerge microtubules.
And these things, the spindle.
Not yet.
Kinetic core.
Well, they're not connect cores yet.
You just divided
Not until they connect. But what's the last?
After that, and synthetase, the DNA duplicates.
One of that.
And then G3.
Okay, guys, so we're going to talk about active and passive transport with this little setup that I've got, this little model, if you will. And we might think about this dividing thing right here as being the what? This might be, if we were talking about 2 cells, if this was a cell here, and this was a cell here, and this was the divider of the 2 cells, it might be a what? Starts with an M. This could be a membrane, right? All right, it could be a membrane. Very good. So if this is a membrane, would it allow some stuff to go through? Yeah. So maybe, like if I had a tennis ball or a bigger ball, a softball, would it let the softball through? No, but it lets these small things through, right? So if it lets some... The negative part of the compound has got to sort of like neutralize or cancel out the positive part. So nitrogen, there's 3 of them, right? What is each nitrogen's charge? 3 negative. But if there's 3 of them, what's the total charge of the anion?
9.
Okay, so let's just write 9. What happened yesterday when we blew into it?
It turned yellow.
It turned yellow yesterday and green, and then we put the plant back in there, and we thought the plant would do what? Photosynthesize and do what with the carbon dioxide? Suck it back out, and that's going to turn it from a what environment back to what? Base back to acidic. And should it be blue in an acidic condition?
Yes.
And is that what happened?
Yes.
Did our lab work?
Yes.
So once again, in biology, we know that
Everything makes sense.
all right, great.